The third and final bond that we're going to go over is the hydrogen bond. This is the weakest of the bonds. This forms between polar molecules where the electrons in the covalent bonds in those molecules are being shared unequally due to electronegativity, which we defined earlier, creating charges in the molecule which attract and repel. Water is a good example. Oxygen is much more electronegative than hydrogen. What does this mean? This means that when we have a water molecule of oxygen and hydrogen covalently bonding, the oxygen in that water molecule will pull the electrons closer to it and therefore will create a negative charge on the oxygen. Whereas the hydrogens, which now have the electrons farther away from their nucleus, will end up having a positive charge on them. Here I have drawn out a water molecule. We have oxygen with 8 protons. We have the first orbital with 2 electrons in it. And the second orbital would have 6 electrons in it if oxygen were by itself, because 6 plus 2 is 8 for a total of 8 electrons. However, we have bonded the oxygen with 2 hydrogens. After all, this is H2O. So let's look at the first hydrogen here with 1 proton. Here is its first orbital, which if you notice is kind of skewed, stretched out, because the electrons are closer to oxygen than to hydrogen. And here is the second hydrogen with 1 proton in the nucleus, and that first orbital stretched out. The reason I stretch them out this way, and I draw them this way, is to show the electronegative power of oxygen. Oxygen, being electronegative, is going to pull these electrons in that covalent bond that it's formed with hydrogen closer to its core, closer to its nucleus. And it's going to do that for both of these. It just means it's a little bit greedy when it comes to covalent bonds. It doesn't like to share them very equally. What happens is because these electrons are closer to oxygen, the overall charge of that oxygen will tend to be negative, and so we draw this minus sign on it. The hydrogens, on the other hand, will have that positive proton in the nucleus, but the electrons that are being shared with oxygen so far away from its nucleus that they will tend to have positive charges on them. And so we draw these plus signs on the hydrogens. What does this mean in terms of molecules of water interacting with other molecules of water? So I drew the shorthand version of these molecules over here, and I drew them so that we can see their interactions. Let's take this first one here. You've got the oxygen bonded with a hydrogen over here and another hydrogen over there. And notice that I put that negative sign, that minus sign on the oxygen, and the positive signs on the hydrogens. So that's one water molecule. That's an H2, right? 2 H's and an O, H2O. That's our first molecule. Our second molecule is this one right here with this negative oxygen and these two positive hydrogens. Our third one is this one. Our fourth water molecule is this one. Our fifth one is over here. And our sixth one is this one, for a total of 6 water molecules and how they interact. What you should notice here is that if we take this hydrogen, notice it is pointing towards and closer to the oxygen of the next one because it is attracted to it because of those opposite charges. And conversely, it is trying to stay away from the other hydrogens that are on the second molecule. We draw a dotted line, in this case, this line right here, to show that attraction. And that is the hydrogen bond. That dotted line is the hydrogen bond that forms between those two water molecules. Let's look at the second hydrogen bond that we formed. We look at the second water molecule and its hydrogen pointing and being attracted to the oxygen on the next water molecule. And this dotted line represents the hydrogen bond. And we can see this over and over again as a pattern forming. Let's take this third water molecule. Its oxygen is attracted to the hydrogen of the next atom, and so on and so forth, creating these hydrogen bonds between water molecules. This creates a tension in water. We call it surface tension. And if you've ever dived into a swimming pool and felt your body crashing onto the surface of the water surface, you know exactly what those hydrogen bonds feel like when you crash into them.